Hello dear students, in the previous lecture I have discussed about the motion of an object in the horizontal surface, and from that we have derived the formula for acceleration. Tell me the formula for acceleration. I hope you remember it. What is the formula for acceleration? Yes, you are right. A is equal to F minus Fk by m, or F minus mu mg by m. That's all. So we can apply that acceleration in our kinematics equations, and we have solved the worksheet also. I hope you have tried some problems from reference materials. If you have any doubts, you can WhatsApp me. You will get the replies. Okay. Today I am going to explain a very beautiful concept, that is motion of an object on an inclined plane. This inclined plane could be rough or smooth or both. Okay, so let us study all the cases one by one. As we are discussing about friction, generally we deal about the motion of an object along the rough inclined plane only. There is a special case what happens if it is smooth. So in one line we will study that smooth surface. First let us see how a rough inclined surface will be. Generally we call this as a horizontal surface, and this is said to be an inclined surface. If an object is kept on the horizontal surface, it will not slide by itself. But when the same object is kept on a rough inclined surface, there are chances for the object to slide. So let us see in what condition it slides. If the object is kept here and this is our inclined plane, I am increasing the inclination. See here, if you compare it with the horizontal surface, the inclination is gradually increasing. It is not sliding at this incline. I have gradually increased the angle. Yeah, still it's not sliding. Yeah, it is about to slide and it slides. So at particular angle it starts sliding. Beyond that angle it definitely slides. Angle of repose. What is angle of repose? The particular angle at which it starts sliding, or it is about to slide, it is ready to slide. That particular angle of inclination is called as angle of repose. Okay. So mathematically today let us study more about our motion of an object on a rough inclined surface. Now I would like to draw an inclined surface and let us see what forces are acting on it. So this is theta, angle of the inclination. An object of mass m is kept on the inclined surface. Now let us see what are the forces are acting on it. Imagine this is a rough surface and the coefficient of friction between the object and the rough surface is mu. Gravitational force mg acts in the downward direction. Normal reaction acts always perpendicular to the surface. So this is our surface and here I have to draw an normal like this. So this is the normal reaction, acts perpendicular to the surface. Now the object is ready to slide or sliding, whatever it is, means some force is acting in this direction. Because of that force only, some force small f is acting along the inclined plane. That's the reason why the body is ready to slide or slides along the inclined plane. Say that is a small f. So now our target is to find the small f value also. Now as I mentioned, this is rough surface. Friction always acts along the surface and in the direction opposite to the motion. Means friction f s or fk, whatever, acts along the upward direction. If it is at rest, static friction acts in the upward direction. If it is sliding, kinetic friction acts in the upward direction. As the body is moving downwards, friction will be upwards, opposite direction. Now, to find the value of small f and n, I would like to resolve this mg into two perpendicular components. So this is very tricky and important. Let us see how. For that reason, so to resolve mg into two perpendicular components, I am drawing a line. I am extending this line like this, and also I am going to draw a parallel line to the inclined surface like this. These two are parallel lines. If it is theta, definitely this is theta, and this is mg. This line is perpendicular, means this is 90, so this is also 90, means what is this? This is 90 minus theta. Clear? Now, is it like a right angle triangle? For this right angle triangle, I would like to name as OAB. From right angle triangle OAB, it's like opposite side, this is like adjacent side, and this is like hypotenuse. So what is sin theta? Sin theta is equal to opposite side by hypotenuse. So what is the opposite side? AB by hypotenuse is this. This is our hypotenuse, which is nothing but mg. From this, AB is equal to mg sin theta. But what this AB? This is our AB. But see, here theta means actually how much? It is not simple theta. Here theta means this angle. This is nothing but 90 minus theta. So that's why instead of this theta, I have to write 90 minus theta. Where sin 90 minus theta is nothing but cos theta. So that's why AB is equal to mg cos theta. What is AB? AB is the force. AB is nothing but the component of mg acts in the opposite direction to the normal reaction. As the body is not raising, the normal reaction and this AB force or BF force balance each other. These are mg cos theta, and the normal reaction is balanced by mg cos theta. Now again from this triangle, let us discuss about cos theta, cos angle. So cos, what is theta? Is nothing but 90 minus theta. The angle is 90 minus theta is equal to adjacent side by hypotenuse. Adjacent side means AO by hypotenuse is nothing but mg. That implies AO, which is acting in this direction, so it is nothing but F, because of which the body is sliding in the downward direction. So in this direction, the force which is acting is small f, which is equal to small f, which is equal to cos 90 minus theta is nothing but sin theta. So if I send this mg towards this direction, it is mg sin theta. Now what happens if the body is at rest, or if the body is ready to slide? Then the downward force is balanced by friction. That's why the body is at rest. Otherwise, if this F is greater than Fs, it slides. So when the body is at rest, or when the body is ready to slide, then the downward force is equal to friction. F is equal to Fs, which is equal to mg sin theta. Clear? Now when the body is ready to slide, Fs is equal to mg sin theta. Say this is equation number 1. This is equation number 2. Let us do 2 by 1. What I get? Fs by n is equal to mg sin theta by mg cos theta. Cancel. Fs equal to what? As per our previous discussion, mu s into n. So it's mu s into n by n equal to sin theta by cos theta is nothing but tan theta. Got it? So n gets cancelled. So mu s equal to how much? Tan theta. So here this theta is a particular angle. This theta is a particular angle at which the body is ready to slide. This is the particular angle at which the body is ready to slide. That's why this particular angle is called as angle of repose, denoted by alpha. So hence we can write that mu s is equal to tan alpha, where alpha is called as angle of repose. If angle of repose is known, we can find the coefficient of static friction. How? So from this I can say that mu s equal to tan alpha. So if alpha is known, we can find the coefficient of static friction. That's all. So it's very simple and easy to find the coefficient of static friction. Clear?